Now we'll be studying ratios. We're going to focus on ratios as relationships, ratios as fractions, and then we're going to look at word problems that allow us to apply the concept of ratios. Now let's look at ratios as relationships. Ratios are used to express the relationship between two or more quantities. So I can say, express it as quantity 1 to quantity 2, or I can express it as quantity 1 colon quantity 2. Ratios can also be expressed as fractions. Quantity 1 to quantity 2 can be written as quantity 1 divided by quantity 2. So now let's look at an example of how we can deal with this. The ratio of men to women in a Rotary Club is 15 to 22. Express this as a ratio. So let's say men to women, that is 15 to 22. Another way of writing that is 15 and then colon 22. And we're going to express this as a fraction. It is going to be men to women, which is 15 to 22. So this is 15 over 22 is the same as this ratio expressed above. Now let's look at ratios as fractions. Ratios can also show the relationship between individual parts as they relate to the whole part. Now let's look at this example. It says that the ratio of boys to girls in a high school is 3 to 7. What fraction of the high school population is the female population? So let's look at this here. So we have boys to girls, and we have 3 to 7. So what we actually do here is we have, for every 3 boys you have 7 girls. So that tells me that in this ratio we have a total of 10 students. Okay, now we want to find out what fraction is the female population. So we have 7 girls out of 10 students. So this is the fraction that represents the female population of the school. Now, one way to see this also is for the male population, it's going to be 3 over 10. So now when we look at ratio, we say 3 over 10 to 7 over 10. Now we can write this as a fraction, and we have 3 over 10 divided by 7 over 10. And then we have 3 over 10 times 10 over 7. So you can see that this becomes 10 crosses out, so we have 3 over 7. So this is 3 to 7. You can see that either way we still end up with the same ratio, and you can see the relationship between the ratio of a part to the ratio of the whole thing. Now let's look at this. A swimming club has 15 girls and 24 boys. Express this ratio in its simplest form. So let's say girls to boys will be 15 to 24. So that's going to be 15 over 24. We divide this by 3, we get 5, and we divide 24 by 3, we get 8. So when you divide 15 by 3, you get 5. You divide 24 by 3, you get 8. So this ratio is now in the simplest form 5 to 8. Also, if you decide to go the reverse way of saying boys to girls, it'll just be the reverse. It'll be 8 to 5. Now let's look at some other problem here. Miss Kramer's class has 30 students, so we have 30 students in the class. If there are 18 girls in the class, so we have 18 girls. what is the ratio of girls to boys in the class? So if we have 30 students in the class and there are 18 girls, so that tells us that 30 minus 18 would represent the number of boys. So 30 minus 18, we take, this is 2, 1, so 10 minus 8 is 2, 2 minus 1 is 1. So we have 12 boys in this class. What is the ratio of girls to boys? So girls to boys is going to give us 18 to 12. And here we can actually divide by the greatest common factor. So when you walk through it, you see that that is 6. So you divide this by 6, you get 3. You divide 12 by 6, you get 2. So 18 to 12 is the same as 3 to 2. So this is the ratio of girls to boys in this class. So Grace is trying to bake some bread using a recipe. The recipe calls for a 3 to 2 ratio of flour and water. So 3 to 2 ratio of flour and water. So we're saying that if she has 5 cups of water, so 5 cups of water, how many cups of flour will she require? That's unknown. So what we can do here is we can say 3 over 2, that's our ratio, is equal to x over 5. So we have two choices. The best choice I would say here is to find the lowest common denominator of 2 and 5, and that will give us 10, and we multiply both sides by 10. Okay, so this is going to give us 5 here, and this is going to give us 2. So we now have 5 times 3 is equal to 2 times x. Let's divide by 2. Let's divide by 2 on both sides. So 15 over 2 is equal to x. So when we simplify that, we can either say that she's going to require 7.5 cups or 7.5 cups. If you plug this in a calculator, you will get 7.5. But if you want to use the conversion from improper fraction to a mixed number, you will get 7.5. Now, final question here. The ratio of students to teachers at Foster High School is 15 to 1. So, students to teachers is going to be 15 to 1. If the school has 300 students, so the school has 300 students, we want to find out how many teachers the school has. So let's write our ratio as a fraction. So 15 over 1 is equal to 300 over x. So I'm going to multiply both sides by x to get rid of it from the denominator. So 15x is equal to 300, and that's because this x crosses out this x. So now we divide both sides by 15, and we see if you put this in a calculator, or simply put 300, and then we have 15. 30 divided by 15, you have 2. 2 times 15 is 30. We bring down the 0, so we put it right up here. So x is equal to 20. So the school has 20. So this is how you can use ratio to solve real world problems.